just want to make a quick comment to say that back in, I believe was it end of February, I think, or maybe beginning of March of this year, which feels like an eon, a different epoch ago, we actually held a webinar on this topic of the coronavirus meets metabesity. And that was a very well-received webinar, but I'm hoping that in the intervening, what is it, about 7 months, we've learned a lot about the virus, a lot more to be learned as well, and also a lot more about, more discussion about how to think about host immunity, being more adaptive, more resilient and responsive to adaptive immunity, etc. I'm hoping that we can focus and bring to focus sort of our learnings over the past half year or more in this next edition of the discussion about COVID as we kind of close out this conference. Obviously, COVID has been a dominating feature of our year and also of our space in longevity. So there isn't a real moderator for this one. This is a fireside chat. So I would say, Nir, you're always leaning forward, wanting to say something. So maybe I'll give you the mic first, and then you guys can talk around the fireplace and we'll listen.
Thank you very much. And what I want to do now is really shortly go over what we heard and is relevant for the COVID in the last 3 days, and make it easy for Joan to hit it, hit the ball to the target here. But what I want to say, okay, so the next slide, and I want to make both a scientific point and a social point. Look at the mortality of COVID around the world. This is China and Italy and the US and Euro. And you can see that somebody over the age of 80 is 180 times more likely to die than somebody at the age of 20. Or if you want the US statistics, 80% of the deaths are over the age of 70%. Okay, that's a terrible ageism. And it's a terrible ageism for 2 reasons. One is, the terrible social isolation that happened to the elderly, and they're suffering more than anyone anyhow. I can tell you that in my centenarian study, I have 750 centenarians. Well, not all of them are alive, but from those that are alive now, nobody died of an infection, but there's a 106-year-old lady that was lonely, and she stopped eating and drinking and died, and she died. So this is a terrible ageism. I would repurpose what Kamala Harris said for another social deficiency in the United States. This virus has no eyes, but it can see how we look at a certain population. And from an academic perspective, we already went from hope to promise. We know that we can do several things right now with repurposing drug, and yet we let the elderly suffer a lot. Next slide, please. It's just a reminder of what we talked throughout Metabesity, that the major risk factor for death from any disease is aging, but not only it's aging. Look, this is a log scale, right? So here in green is pneumonia, which is actually the cause of death for patient who had viral infection and died from that. And it goes from 1 to 1,000. So aging is the major driver of those diseases. And that's why we know that aging drives the disease, and that's how we came to know how to target the aging process and try to delay it and to stop it and to reverse it in certain ways. Next slide. One of the things that is part of the ageism now is that aging is not being mentioned at all. What is being mentioned more than anything is multimorbidities. And this is from a Nature paper that came early, in March during this epidemic from the UK. And it shows that at age 65, half of the people have more than 2 diseases. The darker it goes, the more diseases they have, up to 8 diseases. This is, for me, the biological aging. If you have more than 2 diseases, you age rapidly. If you have less than 2 diseases, you're aging slowly. Okay, it's still about aging. You cannot make the multimorbidities themselves the cause. The cause is still aging. And in the next slide, I want to make the point that the CDC several weeks ago came up with what are the increased risk of severe COVID-19. And that's in the left. Do you see aging? There's no aging there. Look at the right. What might be an increased risk of severe disease? There's no aging there. How is it possible? How is it possible that we cannot get to anyone and say, hey, aging has a biology. This biology can be targeted. Sometimes it targeted more than stop smoking or something like that. And you cannot recognize that aging is a risk factor for COVID. That's the extent of the COVID problem. So let's leave the anger and let's see what can we do about it. Next slide. So we all show also in different ways this meeting, the hallmarks of aging, and every one of us has a different version. And I think it's most important to know 2 things. First of all, the immune decline and inflammation are part of what those knobs that we can turn on or off, whatever we need, and actually target aging and extend health span and lifespan. Those are 2 of the major things that are part of the COVID. But more important to know is that those are interrelated. In other words, you can use senolytics, for example, and you do influence immune response and inflammation. So when it comes to COVID, we do need to increase immunity. We do need to decrease inflammation. But more than that, or in addition to that, those older adults are going to go through a serious disease and we have to protect them against that. And I want just to say one thing, the immunization, the way it's developed now, most of those vaccines are not going to be effective in the elderly. They're even not going to be tested in the elderly, or they're going to be tested in elderly who's 65 and has less than 2 diseases, okay? That's going to be a problem like it is for the flu. Next. Next slide. So I want to give one example of what we could have done and what we can do better that we haven't, and then leave to Joan to take the rest. So metformin actually targets all the hallmarks of aging, directly or indirectly, because when you fix aging, you fix a lot of things. And metformin is this drug that is in use. It extends health span and lifespan of many animals, including fish recently. It's generic, it's safe, it's cheap. Metformin has been used to prevent influenza and malaria in the 1950s and as an anti-diabetic drug for the last 60 years. So it's used all over the world and it targets aging. Next slide. And we know from clinical studies on metformin, an associated study on metformin, that they can prevent diabetes, they prevent cancer, they can prevent cognitive decline, and people on metformin with diabetes have less mortality than people who don't have diabetes even. And those are studies that have been done, that haven't been done in a context of aging, but those are many age-related disease. You know, if you think that by chance metformin happens to do something specific for every disease, good luck for you. But we know, no, it targets aging because it works on animals as much. And the point about metformin, next slide, that metformin does have a specific immune effects. And I'm not going to show it. Those slides will be available to you, but on neutrophil and lymphocytes and M2 macrophage and inhibiting M1 macrophage, all the things we want the immune response to do. And Next slide. The first study appeared in March from China, where they've noticed on 279 patients, out of them 104 are metformin, that their mortality was 20% of those who were not on metformin. And around the world, there are 8 more studies that I'm summarizing now, but in the next slide, which is my last slide, there's a summary of a paper that was published that shows that in an analysis, people with metformin had less hospitalization, just like in China, and people on metformin had less mortality. So the point is that we have a drug that can enhance immunity. We should use it in time like that, and we should use it before we vaccinate patients. And I think Joan can take it from there. I just want to close and say that COVID-19, as Tina said before, many others said before, is an opportunity for us. We cannot have this ageism, not from a social point of view and not from a biological point of view. We can do much better. Thank you.
Go ahead, Joan.
Okay, could I get my slides? Great. So I'm going to talk about work we've been doing to develop therapies to improve antiviral immunity in older adults. And if I could have the next slide. So just as Nir just beautifully pointed out, a person's age is the strongest predictor of their risk of dying from COVID-19. We all know this now. And one of the reasons that Nir just talked about is because of dysfunction of the aging immune system. And I think as we've talked about in this conference in many of the sessions, this is really interesting because it's an area of medicine that's been mostly ignored by drug developers, but whose importance is highlighted by the pandemic. So next slide. So one of the key problems with our immune system as we age is we have a decreased ability to produce a class of molecules called type 1 interferons. And these are our first line of defense against viral infections. So when a virus infects a cell, it's recognized by a group of receptors in the cell called pattern recognition receptors, and this leads to the production of type 1 interferons. The type 1 interferons are then released and bind to interferon receptors and end up in generating the production of a bunch of antiviral, hundreds of antiviral genes and proteins that inhibit the replication of many different kinds of viruses. So this is just an essential part of the immune response to viruses. Next slide. The problem as we get older is we have a decreased ability to mount this interferon response. So on the left is an experiment where they took whole blood from males and females who are either 20 to 35 years old or over 50. And they exposed the blood to herpes simplex virus and found there's a significant diminution in the ability of the blood cells from older adults to produce type 1 interferon in response to this virus. And similarly, these kinds of experiments have been done in lots of labs. On the right is an experiment looking at monocytes from people either 20 to 33 years old on the left or 65 to 89 years old on the right. And when these monocytes are infected with influenza, they can't mount, from monocytes from older adults, have a deficient interferon production. So next slide. This deficiency in type 1 interferon production as we get older is probably particularly bad for people infected with SARS-CoV-2 who develop COVID-19, because increasing data is showing that interferon is just critical for fighting COVID-19. So this is a graph of people who either have mild or moderate COVID-19 in the blue bars, or severe or critical COVID-19 in the black and red bars. And what you can see is the people with the severe and critical COVID-19 on the right-hand side have lower levels of interferon in their blood than people with milder disease. And on the right-hand side, they have a lower expression of these antiviral genes that interferon induces. And then What's really interesting is papers that have come out in Science in the last couple of weeks have shown that a significant percentage of people who have life-threatening COVID-19 pneumonia have either genetic defects in interferon pathways or neutralizing autoantibodies to interferon. And this just highlights the importance of this pathway for fighting COVID-19 and points to one of the reasons why older adults probably are getting so sick, because they already have deficiencies in this part of our immune response. So next slide. So this, of course, raises the question of whether we can develop drugs that enhance interferon-induced antiviral immunity to protect older adults from viral respiratory tract infections such as COVID-19. And for the rest of the slides, I'm just going to go over some data we've generated with a compound called RTB101 at resTORbio to sort of give lessons learned. So RTB101 is a small molecule that inhibits mTOR, which is a key mechanism involved in aging biology. And we use this molecule to say, can we enhance immune function in older adults by inhibiting mTOR? We had some positive phase 2 data and then a negative phase 3 trial, which had a different endpoint than the phase 2 trial. So clearly more work needs to be done on what's the right endpoint for drugs like RTB101 and what's the right trial design. But I thought I'd go over what we did learn about what RTB101 does. So next slide. So one of the things we consistently see in every trial we've done when older adults are treated with this mTOR inhibitor is that they have enhanced interferon-induced antiviral gene expression. So these are graphs of 20 different interferon-induced antiviral genes. And in each graph on the left is shown the change in levels of these expression of these antiviral genes in people treated with placebo, and on the right in people treated with RTB101. So you can see in both phase 2B and phase 3 trials in over almost 2,000 older adults, we consistently see an upregulation of these antiviral genes. So next slide. So what do these antiviral genes do? Well, this is a cartoon of the replicative cycle of a typical virus, such as coronavirus. And each of those green rectangles show genes that are upregulated by RTB101. And they're interferon-induced antiviral genes that inhibit multiple different steps along that viral replicative cycle. So then the question is, okay, we know now RTB101 can upregulate these antiviral genes, but does that lead to any treatment effect? Does it reduce the incidence or severity of viral respiratory tract infections? So I'm going to focus down on coronavirus infections because we want to see if this might have some benefit for COVID-19, given the importance of interferon for COVID-19. So next slide. So this is data from the phase 2B and phase 3 trial looking at the different viruses that cause respiratory tract infections in the trials and the number of respiratory tract infection caused by each of these viruses in people treated with RTB101 in blue and placebo in gray. So again, honing down on coronavirus, there was a decreased incidence in coronavirus infections in people treated with RTB101 in both the phase 2B trial and the phase 3 trial. Although the numbers are too small to assess statistical significance, the trends were the same. And so you can see the same trend when you pool the data. Next slide. We then wanted to look at this, are we able to decrease severe respiratory tract infections? And we see, although the numbers again are small, a bigger treatment effect when looking at severity in this slide than incidence in the previous slide. In both the phase 2B and the phase 3 trial, there was a decrease in the incidence of severe coronavirus infections. And you can see there's, of course, a similar treatment effect when you pool the data. What was also interesting is this decreased severity was also seen with other viruses, rhinoviruses and influenza viruses, and the trends were the same in the phase 2B and the phase 3 trial. Why this is interesting is that the recent papers have come out showing that coronavirus and influenza viruses suppress and delay the host interferon responses, whereas two viruses where we didn't see a treatment effect, parainfluenza and RSV, don't. And so as we digest the data from these trials, what the data may be revealing is that drugs that enhance interferon responses in older adults are going to have a greater treatment benefit for some viruses than in others, and the treatment benefit may be most with viruses that suppress the host interferon responses. So next slide. So our current model is that when older adults who have deficient interferon responses are infected with at least some viruses, they aren't able to control the viral infection adequately, and they develop more severe infections than do younger adults. In people who are treated with RTB101 and other drugs that enhance interferon-induced immunity, they may be better able to control the viral replication, and they have less severe infections. So the next slide. So just in conclusion, dysfunction of the aging immune system is an area of medicine that has been mostly ignored by drug developers, but whose importance is highlighted by the COVID-19 pandemic. And I think this is opening up a whole new area of drug development. RTB101 provides evidence of the feasibility of safely targeting aspects of immune dysfunction in older adults, in this case, deficient interferon-induced antiviral responses. And I think the inconsistent results in our trials to date point to the fact that we've got to refine the endpoints in these trials. And trials of RTB101 as COVID-19 post-exposure prophylaxis in older adults are ongoing, because targeting specific viruses may be a better endpoint than just any viral infection. So I'll stop there.
Terrific. Thank you so much, Joe. Larry, can we cue up Larry's slide? Caitlin?
Hi. Good afternoon, everyone. So I would like to talk about the two matters. The second matter will be the most important, and that is I want to say a few words about the so-called Great Barrington Declaration and what it will do to the aged population. But before I talk about that grotesque idea, let me tell you what we've been doing. So here I am at a meeting on aging. It's suitable for me because of my age, but my professional focus has more been on pediatrics. So it's been important to understand a lot of phenomena, to look at extremes of outcome. So here we have the issue, as Nir and Joan pointed out, that the most susceptible to this viral infection are the aged. 80% of deaths in the United States are in the older populations. And children, on the other hand, especially younger children, are remarkably resistant to getting hospitalized. So there you have built in, what is different about the older immune system and the older respiratory tract compared to the younger respiratory tract? And first we need to realize that the children usually encompass the age range 0 to 18, but there's a significant difference about adolescents compared to the very young. And one of the questions that first drove me to study this is, I asked my colleagues in infectious disease, tell me any viral infections that spare children so well. It's certainly not true for tuberculosis. Somebody came up with Legionnaire's disease. I wasn't so sure about that. Generally, children are very susceptible to respiratory infections, and you don't see this striking disparity. So you could go down the list in this schematic. On the left is an adult, and it's everything I say about an adult is ever more true about older adults, and everything I say about children is ever more true about the younger children compared to a 16-year-old so-called child or adolescent. So to begin with, the respiratory tract of the very young has a much lower level of receptor. That's one of the most constant findings, whether it's in the nose or in the alveoli. So the receptor for the COVID virus is ACE2, and there's far less ACE2 in the nose and in the respiratory tract. The second major difference is relates to Joan's study on coronaviruses. So children actually have about 4 to 6 respiratory tract infections a year. You often see younger children running around with all sorts of stuff coming out of their nose of various colors. And many of those infections are common coronaviruses. So it's very interesting that the common coronaviruses oddly downregulate ACE2. So there may be some benefit and some protection from the common cold compared to SARS-CoV-2. This brings up the issue of driving interferon responses. So the more ACE2, the more interferon gets driven. So children, oddly, are probably having lower type 1 interferon responses, and they also have lower cytokine responses. So here's another paradox, and by the other cytokines, I'm primarily talking about IL-6, TNF, and gamma interferon. So here's what's really puzzling about immune responses. In studies that have appeared in Science and Nature, a very good study came out of Albert Einstein by Betsy Harold, who collaborated with her husband, Kevin Harold, who's a star in the diabetes field. It turns out that the people with some of the highest antibody responses are those COVID patients who are actually hospitalized. So you could say that their viral loads might be higher because they're not dealing well with it. It might be because they've been exposed for longer periods of time, but it's very worrisome. If the highest viral titers that we see in patients have the highest antibody levels, then what are we going after with a vaccine that's supposed to be driving a good adaptive immune response, which consists of making antibodies and making strong T-cell responses? So it's a puzzle. The other thing is what finally causes the demise, kills people with COVID infection. It's not that they're like HIV patients, that they don't mount a good immune response. It's because they have cytokine storms. And you know the amount of attention that's been given to cytokine storm. The average person on the street, you can hear them buying a hot dog on a street corner from a street vendor, and they're talking about cytokine storms, and you feel like everyone knows immunology these days. What's going on here? But joking aside, this is a puzzle. Too much immunity is no good. Too little immunity is oddly somewhat protective. And the more I talk about it, the more I realize that this is such a work in progress, but this virus is not behaving like many of the other convenient models that we have. So this gets to the other issue. So if children don't get hospitalized very much, well, first of all, who gets hospitalized in the childhood ages? Many of the risk factors that are notable, the most notable is obese children are more likely to get hospitalized. So there you get into the comorbidities. Generally, children have fewer comorbidities, fortunately, than we older people have. So those comorbidities, whether it's obesity and its impact on the immune system, whether it's hypertension or cardiovascular disease, renders the adult at risk. And it may be because of the pathophysiology of the metabesic diseases that's driving the bad outcome. But this raises the other question that I wanted to get to, and it gets more into sociology and socioeconomics. Even though children are far less susceptible, they can carry the virus and spread it. And this brings up the Grotesque Barrington Declaration. And two of the signatories of that are my colleagues at Stanford, Scott Atlas, and another internal medicine epidemiology person named Jay Bhattacharya. So they're saying that let's get herd immunity going, and essentially the way you do that is you sequester, and the euphemism is hideous, the old people somewhere, and let the younger people party on, and a few of them might get sick, but they'll then attenuate the virus. So first of all, in the most literal translation of that, what do you do with the old people? If the old people are part of an extended family living in a small living space, and children are out trying to go to school, and mom and dad are driving buses and working in close quarters in a grocery store, they're going to all come home from work, and it's the older people and grandma and grandpa that are going to get infected by the people who are out there who are carrying the virus. So I just don't see how that grotesque idea of letting the virus rip through the population is at all tenable, both on an ethical, humane basis. And there are other simple public health measures that would work in a much more humane way. And, you know, we can all say it, and we should say it many times a day to people: wear a mask, socially distance yourself, and essentially don't do stupid things like congregate in large groups without a mask indoors. And thereby, with all of the uncertainties about vaccines and whether too much immunity or too little immunity is a benefit or a risk, public health can get rid of this problem faster than we're going to be able to with all of the highfalutin programs that Warp Speed has invested in. Thank goodness we are trying the vaccines, and we're trying the monoclonal antibodies, and we're trying the antivirals, but look at China, look at Taiwan, look at Singapore. They've dealt with it by just being intelligent, and they have certain enforcement powers that we're not willing to do in the United States, but we better get serious. So that's all I have to say at this juncture, and I think we can have a lively discussion.
Thank you, panelists. Please go ahead, break into conversation.
This is my approach to aging, also to look at the resilient, right? The people are resilient, what we learn about them. You're looking at kids. So one of the difference is kids have thymus. Do you think this plays a role? Because there's a lot of effort we heard to rejuvenate thymus. And a second question, it seems that around the world, people who had BCG for prevention of tuberculosis are immune to severe COVID disease. Do you think it's part of what we're seeing?
Well, there is some cross-reactivity. The studies on BCG are quite interesting. Also, MMR vaccine, mumps, measles, rubella, is said to give some lower level of cross-reactive protection. There are common structural domains of rubella and measles that resemble the SARS-CoV-2 spike protein. So there may be benefit of that. So that was in our perspective on children. Those other vaccinations may play some role. We may bless the common cold if the emerging data is telling us that people before they had the SARS-CoV-2 virus had antibodies and T-cell responses to the SARS-CoV-2 virus. Where did they get those? And it turns out they got them from the very viruses that were on Joan's slide, HKU, OC43, and the other ones. So I'm not telling people to go have a common cold party with their friends, and it's going to be really frightening when any of us come down with a wintertime common cold. Is this the beginning of my bout with COVID-19? There are differences between the common cold and how you're going to feel if you get a SARS-CoV-2 infection. But the common cold may turn out to be a blessing and a curse, not because it makes you feel bad for a little while, but because we all know that immunity doesn't last that long to common cold viruses, or so it seems from the studies. So does that mean if we get our primary and booster from the vaccines that are left standing, that 6 to 8 months later, they're not going to be any good anyway? I don't know. We don't know. The community doesn't know. So there's a lot of work in progress. So if we don't know all this, and we're learning as we go along, public health, because look how well it's worked on the eastern side of the world.
I think we have some questions from the audience that maybe we can take on one by one. So the first one's from Dale Abel, and it was, how long do patients need to be on RTB-101 before you see an immunologic benefit? What would be the window for starting it in relation to a viral infection? It's a great question, Dale. We've only looked at 6 weeks after starting drug and see that the antiviral gene expression is up at 6 weeks. And so we want to look at 24 hours and just haven't done that study yet. My guess is it upregulates quickly based on data, preclinical data. So we'd like to get it started before the viral infection to give it time to get up as a prophylactic. And then hopefully that will sort of set the immune system at a point that it can respond better to the virus. Then there's a question for Dear. Do you think we need a lexicon for longevity? Having a more positive language that is consistently applied could do wonders to dispel myths, reduce ageism, and encourage more businesses to invest in products and services to keep us healthy and well, and make the general public feel more empowered and less afraid of growing older. This keeps coming up over and over again in my discussions, and that's from Tina Woods. So
that's Tina Woods, and thank you, Tina. And the danger when you're asking a question, if I say yes, by tomorrow I'm going to have 10 pages of how you're dealing with it. So yes, Tina, we need that. The only thing that I'm noticing, because people have commented about that I'm not saying old, I'm not saying elderly, we're saying older adults, but the ageism really goes everywhere. That's the point I made, right? It goes to science. It's really very frustrating. And yeah, if a lexicon could help, then please provide it. You know, you're the English person, not me. I see Barb Nick was asking what was the comparator diabetes drug in the study that showed that metformin helped people to do better? Well, I didn't show any study. Well, I showed a study on COVID. From all the studies on metformin, there are lots of clinical studies. So the DPP had a placebo as a control, and the UK PDS had sulfonylurea and insulin. The UK study that showed decreased mortality showed it compared to control and showed what happened to people who were not on metformin but on sulfonylurea that had worse outcomes. So I think it's good to know what was the comparator in clinical studies. The rest of the studies were not clinical, were observational studies. I want to make just one thing clear, that what Joan and I suggested with our examples is that we can fortify the host. This was not a virus-specific thing. I mean, Joan's data was on influenza, right? My data was more on COVID, but for the next epidemic, we have to be better prepared and fortify the host because we can improve immunity.
Then there's a question from Zoe Du. Is there a decline or increase in interferon baseline levels with aging when there is no viral infection? It's a great question, Zoe. I don't think there's good data on this. There's good data that other inflammatory cytokines such as IL-6 and TNF-alpha are increased with aging, but not so much that I'm aware of the type 1 interferons. What's very clear though is that cells like dendritic cells, which are a major producer of type 1 interferons, they just fail to produce normal levels when they're stimulated either with TLR agonists or viruses. There is a defect in the ability to produce this in the setting of an infection. And then there's a question, maybe it's Felipe Sierra, I don't know.
Yeah, it's Felipe.
Yeah, I just see his initial. How long will it take for the results of the current RTB 101 trial on COVID to become available? They could change the conversation. I hope you're right if this is Felipe. We are currently enrolling 2 different trials. One's in nursing homes and one is actually a National Institutes of Aging sponsored trial in people 65 and older as post-exposure prophylaxis. And so it's going to depend on how long those trials take to enroll, but I hope you're right, they succeed and we can change the conversation. And then we have a question for Larry. What are your perspectives on Regeneron and the Lilly antibody approach as therapies?
Well, let me start with the Lilly approach. For unknown reasons, it's on hold. There, I'm talking about their antibody therapy. Number 2 with Regeneron, and I hope it works. There was a famous patient who got the Regeneron antibody, but he also got dexamethasone and remdesivir, and we don't know what effect it has. Let me just say about passive antibody therapy. We've known about it for a long time. It's always been part of the armamentarium for giving hyperimmune globulins to people. That's fine. The problem with hyperimmune globulins is it doesn't allow you to mount your own natural immune response to the virus, should you either be infected or get a vaccine. So after the Regeneron antibody would get out of your system, after a couple of half-lives of antibody infusion, you'd be right back to the baseline. I wouldn't advocate giving somebody an immunization after they had passive antibody therapy because we know that interferes with developing your own immune response. So yes, hyperimmune approaches are useful. It would be important to know what's going on with the Eli Lilly problem. Is it because they saw antibody-dependent enhancement of the immune response, the kind of thing that's seen with dengue virus and dengue vaccination, or is it something else? Was it merely allergic responses, even though they're fully human antibodies? We just don't know because of the opacity of the communications in the world. So right now, just to go through, so that's, you asked about Regeneron and Eli Lilly. Let's go to the vaccine front. J&J is on hold because something happened to a patient that the DSMB really is worried about, but we don't know what's going on. Something happened with AstraZeneca UK vaccine. They're both adenovirus vaccines because people got inflammatory neurologic disease, transverse myelitis. For reasons that might have to do with politics, it's back on trial in the UK, but the FDA has not allowed the AstraZeneca Oxford vaccine to go back on trial in the US. It's now been on hold for approximately 3 weeks. So that's 2 of the major vaccines done by 2 of the most experienced vaccine developers, AZ and J&J. There's others obviously out there, but the whole vaccine issue, if we get a vaccine that's, let's say, as good as or as imperfect as the influenza vaccine, we're still going to need, and you've heard me say it 11 times already, public health measures. Social distancing, wearing a mask, not doing stupid things like going to a bar and yucking it up with your friends indoors. And that will make the virus go away probably faster than the vaccines. All the people whom I respect greatly, starting with Tony Fauci, will say that if they, even Redfield says, if I had one or the other, I'd take the mask and the intelligent public health measures as opposed to the vaccine. Obviously, let's have both, but it'll go away if we do what they did in Taiwan, China, Singapore. Why are they so much smarter than we are? It's the political will to get rid of it. But we're getting screwed because of an ignorant approach.
Okay, we have another vaccine question, which is, to the extent that live vaccines in general provide trained immunity, not just BCG, do you think there is a potential win in FluMist instead of flu shots? And I think that's a Larry question.
Well, there may be some benefit by ramping up the immune system. The FluMist will increase interferon responses. I don't know of any cross-reactive domains between flu and SARS-CoV-2, but probably the live virus in the respiratory system is going to be better than a shot in the arm with a component virus, but there's no data on that. Many things that we would like to be able to answer just don't have the data, and then sometimes when we have the data, it raises all sorts of questions like, why do the people who are the sickest and oldest make the most antibodies? Wow, that's an inconvenient truth.
And then last, I guess we only have 2 minutes. I love this question. For Mohammed, how can well-being and positive attitude in life help in fighting COVID-19 and in longevity? And I would just like to say we always have a placebo control in our trials, and the placebo effect is remarkable. In our phase 3 trial, large numbers of people on placebo reported that they were having less severe respiratory tract infections and fewer respiratory tract infections than ever before. So I have no idea if this was just mind over body or it was, a placebo effect, but we see remarkable feeling better in people getting placebo. So a good attitude probably does help.
I'm sorry to intervene. Yes. This has been a terrific discussion. We have reached the end of our time for this, and this is a conversation that actually is probably going to go on for months or years, and hopefully not too long.